Find an equation of the tangent line to the curve y equals 2x sine x at the point pi halves, comma, pi. Of course, if we want to know the tangent line, we're going to need to know its slope, which means we're going to need the derivative. So let's differentiate y with respect to x. Here we can see that our function is a product of two smaller functions. It is 2x times sine of x. You could actually leave the 2 out front, it doesn't quite matter, but let's just split it up that way. That seems to be the simplest way. So when we are taking the derivative of a product, we have the derivative of the first function, the derivative of 2x is 2, times the second function, which is sine x, plus the derivative of the second function, the derivative of sine x is cosine of x, times the first function, which is 2x. And I'm just going to rewrite this and take the second part and put that 2x out front. Looks a little bit nicer that way. So we have our derivative is 2 sine of x plus 2x cosine of x. And we want to evaluate this when x equals pi halves. So we want dy over dx when x equals pi halves. Let's evaluate these at pi halves. So we have 2 times sine of pi halves plus 2 times pi halves times cosine of pi halves. And we know that cosine of pi halves is actually 0. So this whole second term is going to go away. Sine of pi halves is 1. So this is going to be 2 times 1 plus a bunch of stuff times 0, which gives us 2. So we know the slope of the tangent line is going to be 2. So we can use point slope form. Y minus y1 equals m times x minus x1. So that gives us y minus pi, it's the y coordinate of the point, equals 2 times x minus the x coordinate, pi halves. When we distribute that 2 on the right-hand side, this gives us 2x minus, and then 2 times pi halves is just pi. And then if we add pi to both sides, that gets rid of those negative pi's, and we're left with y equals 2x, which is our equation.